Hello and welcome back to my corner of the internet. My name's Rob, and today we're going to be talking about a couple of tips for the SOLIDWORKS surfacing exam. This video is a result of a poll on my YouTube community page. I asked what certification video should I work on next, and you guys voted for surfacing, and that is a fine choice. But if you voted for something else, don't worry, because I plan to get to all of them eventually. SOLIDWORKS surfacing is really near and dear to my heart. Just seeing what can come of them and the process of making them endlessly fascinates me, and still does to this day. Not really sure why, but departing from regular prismatic geometry is an adventure that I truly enjoy. There's something really special about the ability to express yourself in the look and feel of a part. It is my belief that if you are comfortable with these tips, then you should have a good shot at the exam. Keep in mind that I won't go into the specifics of every technique that I mention here, it's just not that kind of tutorial. But if you want me to elaborate on something, just let me know in the comments, I'll respond to it, or if it needs its own video, we'll do that too. And with that, let's get to the tips. So the first tip here stems from a question that I get very often, and it is, what is the difference between loft and boundary surface? What I hear a lot is, I want to take the surfacing exam, but I really shouldn't because I don't know exactly when I should use loft and when I should use boundary. And I say, don't let that get to you. Loft and boundary are practically sister features. They are very similar in what they accomplish. Don't get me wrong, they are a little bit different in how they compute stuff. So an example here is I have three curves. I just have these two splines that are oppositely opposed from each other, and then to the side here I have this other spline that kind of connects them. So I connect them together with a boundary surface, so I'll show that body here. So I have it colored in yellow, and these are just with the basic settings. So direction one sketch to the other, and then direction 2 is the other sketch, and no tangency settings set. I just leave everything as is. Loft I set up similarly, just connect them together, and if I hide this, it is this green surface. But you can see when I show both of these together that over here it's showing green, and to the other side it's showing yellow. That means that on this region here, the loft extends just a little bit higher than the boundary surface does, and then dips below the boundary surface. So the boundary surface is slightly more flat, and the lofted surface is slightly more extreme in taking that path. It's explained even in official SOLIDWORKS literature that if you get a result that you like in boundary, and this goes for just general engineering and industrial design, if you get the result that you like using a particular feature, then that is in it of itself a correct solution. So the way that they ask for the answers on this test mostly is either they have you patch a solid body and ask you for the mass, or they will have you create a surface and will ask you for its surface area, which you can find with the measure tool pretty easily. If I go here, measure, just click on a surface, and it'll give you the area just like that. So with these two, the area will probably be exactly identical. I would expect the loft to be slightly more. Let me see. So this is 24.994 clear, and this is 25. So you can see they're a little bit different, but that is accounted for in the SOLIDWORKS surfacing exam. There's a little bit of tolerance there that you're allowed to be off by, and that's not going to be affected by your choice of loft versus boundary. So tip number 1, don't worry about the difference between loft and boundary. Just use what you feel most comfortable with. That being said, I do have a personal preference. So basically the way I decide is basically I use boundary surface practically every single time. And the reason I use boundary surface every time is that it comes with these little convenient flags that I like. So if I need to really quickly change the tangency factor from one face to another, I have these flags. And also boundary can actually extend it can extend the profiles beyond these two blue ones. So if I extend this purple one, I can actually get it to fly out here. Let me see if it can do that actually. Let me try. One sec. Alright, so there, just like that. So you can see there's my two initial sketches, but you can see the boundary can actually extend that past by going by direction 2. Loft is not able to do that. But Loft actually has a little superpower too, and that is its centerline functionality. If you go here, and I won't demonstrate it here, but if you go to centerline parameters, you can actually treat this like a sweep. So if you ever thought, golly gee, I like sweeps, but I want to sweep a square into a circle, you use a loft with centerline parameters. I don't want to get too deep in the weeds in this video, but let me know if you want a boundary versus loft video. I'd be happy to do one, and I think it's very interesting. All right, let's go on to the next one. So for tip number 2, avoid degenerate surfaces. So degenerate surfaces happens when the underlying curves of a surface converge into a point. And to explain what that means a little bit, actually, let me go get the other part that I had. All right, so yeah, we can see here's one of my surfaces. And it doesn't really matter if I demonstrated the loft or the boundary. They're both non-degenerate surfaces, which is typically what you want. So SOLIDWORKS has these curves that it considers and kind of blends it together. And you want these curves, for the most part, to be nice and evenly spaced. You can actually see the underlying curves using a command called face curves. So I'm just going to search for it up here. Face curves, and I click one of these. Yeah, you can see those are the underlying curves. And you can see no matter how many I try to put on these, they never converge into a point. But take this surface for instance, if I use face curves on that, you can see that the blue curves that go across are just fine. The pink curves, however, converge into a point. So let's talk about how that happens and how to avoid it, and then I'll talk about why you should avoid it. So how did this happen? Well, there are a lot of features that like to be four-sided. And among those are loft and boundary surface. So the two sister features that I mentioned, they like to be four-sided. And so you should only use them for four-sided patches. This here, let me get that and show these sketches. This is a two-sided patch. So what happens if you use a loft on that, the loft still wants to be four-sided, but basically what happens is that it has two sides that have a non-zero length, and then two quote-unquote sides that have 0 length, or a point. So basically the rule of thumb is that loft and boundary, and swept surface to an extent, you want to use those for four-sided patches if you're trying to patch up a model. Everything else used fill surface, because fill surface is a bit different. It actually takes a four-sided surface, fits it to your selection, and just trims around it, leaving a non-degenerate surface. So let me try and show you what I mean. Here I have a two-sided patch. 2 is not 4, so we're going to use a fill surface. So filled surface, make sure optimized surface is off, because for some reason optimized surface actually allows you to create degenerate surfaces. But if I just pick these two, you can see it creates a surface to bound those two together. But if I go get my face curves on that, you can see that this is a non-degenerate surface. It actually put a four-sided patch that touches all of those curves and just trims them down. And so this is what you want most of the time versus degenerate surfaces. All right, so now I told you how that happened, how you can avoid it, but now why you should avoid it. So let me suppress this surface fill. Actually, let me bring it back. I'll just hide it away. Just get our surface loft here. So the thing is, SOLIDWORKS is parametric. It keeps track of those curves that I showed you with face curve. It keeps track of them under the hood, pretty much. So when you do an operation like offset surface or shell, which uses offset surface, it transforms those equations mathematically in order to get you a new resultant surface. you can run into problems with degenerate surfaces because, you know, out here in the center of this surface, it's totally fine because, you know, for any given point, it knows how it should transform that point. If you know, if you're offsetting it like a millimeter, it knows how it should offset that point because there's one and only one curve to listen to. But when you get to the degenerate points, now if I want to offset this 1 millimeter, well, now there's like 5 curves that are converging into a point. Which one does SOLIDWORKS listen to? And a lot of the time, this will bite you. So let's try and do a little exercise here. I'll try and offset this. Or let's try thicken, actually. I'm going to thicken this surface. 1/10 of an inch is fine. And let me thicken it in the other direction. So you can kind of see. Let me see if I can get a better angle on that. There we go. So those are those degenerate curves that are kind of crossing each other. So let's see what happens when I hit OK. Unable to thicken the surface. It's angry. And this is like the point in the exam where you just hit a wall. It's like, why isn't it letting me thicken this? So let me try something else. So thicken is based on offset surface. So let's just try and do that. So if I offset 1/10 going the other way, you know, typically offsetting to the outside, sometimes it can work, but definitely towards the inside, that's where you'll see more problems. So let's try that. If I hit OK, okay, it did it, but look what it did. This is the resultant surface. For some reason, I clicked through it. This, let me get a different color real quick. What color do you want to be? Want to be pink? Sure thing. This is our offset surface. You might be thinking, well, what the heck did it do with the points? It just kind of lopped it off and just gave you this part. Well, that's kind of a fail-safe mechanism in SOLIDWORKS. You see, contrary to popular belief, SOLIDWORKS does not like to throw errors. It doesn't want to throw errors. It wants to do the most it can. And that's what it's doing here. It really should throw an error, but SOLIDWORKS tries to be smart about it and say, well, you know, if some freaky math stuff is going on here, why not just cut it off? And that's exactly what it does. So that's with a degenerate surface. Let's try this same exercise with the fill surface that I did. So there's my fill surface. First, let's try and thicken it. 1/10 of a millimeter going the opposite direction. If I hit OK, you can see, there you go. Thickens just fine. And now you can move on with your life. And also let me suppress that, and we'll do the offset just for the fun of it. The other way, please. There you go. And now the offset surface, now you get the entire shape there. So tip number 2, avoid degenerate surfaces. They're more trouble than they're worth. All right, so for tip number 3, it's just be comfortable with using splines and tracing out sketch pictures. That's a lot of what the exam is. So for example, this, if I wanted to trace out this top curve here, another point of information, do not sketch directly on the sketch picture sketches, make a new sketch. I think I mentioned that in many of my other videos of this nature. But basically, to trace, you're going to place a point right at the end point, and then you're just playing hills and valleys. So every time you see a hill, you place a thing right there, and every time you see a valley, you'll place one there, but there's no valley, so it's just the one point here, a hill, and then the other end point. Then fix the ends like that. And there you go. You have a wonderful, wonderful spline. So get comfortable with this so that you can do it nice and quick, just like me. You can turn on curvature combs and try and analyze the curvature. Absolutely not necessary for the SOLIDWORKS exam. For the same reason as loft versus boundary, that kind of error is within the tolerance of the tester. So yeah, don't worry about making these combs look perfect. So the way I have them here, A-okay, we'll be totally fine. So definitely another thing you want to consider, don't try to wrestle with splines in 3D unless it's very simple, like a 2-point spline. So yeah, don't do this. So if you look at this sketch picture here, you know, it kind of lines up with this sketch plane, but this one on the bottom actually matches up with this curve here. So it's actually kind of out in 3D space here. Definitely, you don't want to get a 3D sketch and then try and wrestle a spline into place. It's just really a sad time. You're going to waste a lot of time. You could see it just doesn't want to listen. And you know, that's getting kind of close, but they're more trouble than you're worth. So this leads me into tip number 4, where you're going to want to get comfortable with the intersection curve. You want to get comfortable with project curve and things of that nature. So try and make these weird 3D curves in another way. So I like using project curve a lot. So I'll do a quick example here where I'll sketch here. You know, get ourselves maybe a 3-point spline just like we did with the other one. Just like that. We'll take that handle, maybe move that there. Move this handle there. Maybe can move this point back. And just that up a smidge. That's fine. And then on the top, I can probably accomplish this with a 2-point spline. Or maybe even an arc. Yeah, I'd rather use the arc, I suppose. Yeah, any spline work you can save is good, but there you go. That was easy too. But before I leave, you need to put the right relations, and I'll get into that a little bit more when I talk about this next tip here. But if I do that, go to features, curves. Let me get out of this sketch. Features, curves, project curve. And we want that sketch on sketch action. And there we go. There's our project curve. Now, I've seen in some cases that project curve actually doesn't work for one reason or another. So another way you can do it if you're in a pinch is you can actually get your 2 sketches and surface extrude them like that. And it's just got to be far enough. You got to go further than the other sketch. So I'll get that and I'll extrude that as well. And as you can see, the place where they intersect is the curve that we want. So if I go into sketch, convert entity and convert entities and pick the 2 surfaces, okay. And that is another way to get the curve, albeit it will now be in a 3D sketch, but it'll be nice and locked up. A good example of how you can use perhaps a 3D spline but with between 2 points. So if I get 3D sketch, a spline, and if I have 2 points, that makes this a lot more controllable. Although for this, I probably still want to just maybe project it on by drawing this here. But yeah, you have something like that. But yeah, now I can just sketch that last thing if I want and then close it up. But the point is, get comfortable spline sketching and try not to do overly fancy tricks. Sometimes the smaller steps building up to the bigger things is the way to go. So moving on from this, make sure that your skeleton sketches have rigorous sketch relations. So I like to call these things that I'm creating here skeleton sketches because they're not the surfaces themselves, but it's what helps you create the surfaces. It's like it's skeleton. So let's go to an example. All right, so here I have 4 curves set up in a kind of a squarish format, but of course they have their own funky shapes. This is a 4-sided patch, so I can actually use either loft or boundary surface if I want to. So let's try it out here. I'm just going to use boundary. I'm going to click from here to here. All right, so far so good. Direction 2. I'll pick that. All right, and now I just got to pick the other one for direction 2. And no dice. If I go here, it throws an error. And this is yet another reasonable roadblock that you can have when you're taking the exam. And as such, this is a problem that's caused by not having my sketch relations rigorous. So if you have something like this happen, well, so we know it's sketch 3 that's throwing an error. Let's take a closer look there. So let's back out of here. Edit sketch 3. All right, already some of you may already see the issue with this. So, give you a second. All right, on top here, I use a Pierce relation. On the bottom here, I use a coincident relationship. Pierce and coincident are not exactly the same. Pierce is more specific. And this is yet another topic that, could stem into its own video. So if you're interested in that, leave a comment down below. And yeah, the problem is apparent that Pierce uses the specific intersection. So you can see this point, it's locked. I can't move it because it's stuck to where this sketch crosses the sketch plane. Whereas coincident, it's between the end of the spline and this thing. So whenever you have a 2D sketch, it considers how things look from its perspective. So if I go Control 8 for normal 2, you can see that my weird little humpy thing here looks like a line as seen from the sketch plane. And when I make a point coincident to it, for all intents and purposes, it is a line. So if I take this point and I move it away, you can see it was not constrained at all. And if I do Control Z to put it back where it was and zoom in really, really closely, there was a gap. And that means that at this point here, SolidWorks was trying to make a point of a surface be in two locations at once. You can't have that. So the way to fix this is I can get rid of this coincident, and instead I'll replace it with a pierce by grabbing the point in the active sketch and a path in an inactive sketch, and saying instead of coincident, pierce. So you can see that scooched it into place. Let's get out of that sketch and try it again. So boundary from here to here, we're good. So we have that curve, and now this should work perfectly fine. And there's our weird looking surface. So as you can see, making sure your sketch relationships are very rigorous is the key to success with surfaces. All right, so for tip number 6, you're going to want to use your split entities command, your segmenting command, and heal edges accordingly to break up edges into exactly what you need them. You need to be able to manage them. So an example is this blend. So we have these two pipes here, and a reasonable prompt from the exam is like, make this transition between these two pipes nice and smooth. So let's just go for it, right? I'm going to sketch, let's see, is this the front plane or we're the right plane? All right, sketch on the right plane. And I want to trim these two members down, so reasonably. I may start here and go out like that. And have that be coincident, so that will lock it at a particular angle. And actually, it would be better if I overextend it a little bit. Coincident, there we go. And a line similarly over here. So coincident, and here coincident. All right, so let's just roll with this for right now. So I'm going to go to my surfaces, trim surface. It's going to be a standard trim, and let's just say we'll remove these two selections. So now you can see I've got it trimmed up all nice and neat, and it's perfect for my little bridge here. So you can accomplish this with either the boundary or loft. So again, I'm just going to pick boundary. If I pick from here to here, so you can see now we're running into a couple of issues. Even if I set the tangency values, and it looks like this is backwards. Yeah, this is not looking that good. So part of the issue is, well, the locations of these things there. Okay, so now it looks a little bit more regular, but we have too much surface. I only want this, and it's giving me all this outside over here. And this can make some people struggle. So how do you deal with that? And the answer here, or at least I like to do, is with the split entities command. So going back to my trim sketches, I'm just going to search split, if I can spell, split entities. And now I'll just click on each of my lines, and what this will do is it'll split it into two separate lines. Can say make that coincident, make this coincident, and then just leave the sketch. So whenever you segment or you split a line and you use it as a trim tool, it'll actually split those edges. So now if I go into my boundary surface, so I can say from here to here, and oh, looks like we got a little crossy there. And quick way to fix that, right click, flip connectors. There we go. And then now we can set perhaps tangency to face, that is backwards, go the other way. Tangency to face, you're going the right way. And now just look at it from the right and just kind of play around with these arrows here till it looks right. So maybe a little less from you. That looks real. Oop. I was about to say it looks really close and then it jumped. So something like that. You can keep messing around with it. But there you go. There's that blend. And as you can see, because I was cognizant of my split entities command, I was able to conquer this challenge. So what is the opposite of split? Is there anything else? There is. There is something called heal edges. So if I want to undo that, so to speak, so I can just search for heal edges, you know, pick this face, and I just kind of play around with this until I get the result that I want. So maybe I can put the angular tolerance up. Let's try up to 45. Okay, so basically I just bumped these numbers up till they were high enough, and then you could see before 6, after 4, and those edges that were previously split have now fused into one. So that is the reverse reaction. Although I don't use it that often, I don't use heal edges that often. So I more use this next tip that I'm going to show you, which is, you know, the selection managers. All right, so tip number 7. So this is one of my favorite things to use. This is the selection manager. So consider the situation that we have in front of us. We have a nice curvy spline trying to get with this little angly guy over here. And you'll see that we'll have a couple of problems trying to merge these two together. So if I use my boundary surface, my good old trusty boundary surface, I can click here. But if I try and click on the other side, well, it gives me that weird thing. Maybe I can try flip connector, see what that does. Okay, that's a bit better, but I wanted to consider this whole edge here. If I just try and click on it, it doesn't really do what I want. It's trying to go through all of them, where I just want one side connecting to the other. In this case, heal edge won't even help us here because this is angled too extreme. It's not going to be able to merge that into one smooth curve. So what we use instead is the selection manager. So this can be selected normally, so I just clicked it. But for this, I can right click anywhere on my screen and say selection manager, and I'll just use my little bulk select where I can just pick all the members that I want SOLIDWORKS to consider as one curve. So those 3, so you hit OK when you're done, and there you go. Now I can set my constraints if I want to. I'm gonna play around with the little arrows if that's what suits you. Maybe not to the point where it starts intersecting itself. Get back. There we go. I'll just do something like that. Hit OK. And now it's done. So using the selection manager, we can also manage how SOLIDWORKS considers a system of edges pretty much. So the astute of you may notice that my 3 surface bodies here are not combined yet. They need to be knit. And that actually brings me to my next tip. So tip number 8, you gotta get comfortable with the mechanics of knitting and the knit tool in general. So there's a couple of rules when it comes to knitting things together, and allow me to get something here to demonstrate. All right, so here I have a little exercise, and let's talk about the rules of knitting a surface together. So the rules of knitting are as follows. 1, there must be more than one body, more than one surface body, that is. You know, seems obvious, but for reasons I'll go over later, that can trip people up. So it's got to be more than one body. All the surface bodies must touch edge to edge. You can't touch anywhere that is not an edge. And disjoint bodies cannot be knit. So if your 2 surfaces are apart, they're not going to knit. That one's another pretty obvious one. But you can see here we have 2, well, let me roll this back. we have two surface bodies, which is greater than one, so that's good. It's touching edge to edge, which is good. And it's not touching anywhere that is, for example, in the middle of the face. So in theory, this should knit together. So if I launch my knit, have those two, and hit OK, indeed, it works. Works perfectly fine. So where you have to be extra careful is in a case like this. So now I have this other body here, and you can see it looks pretty close to knitting together, but why did I get fillet? Knit. If I try and knit these together, you can see these are disjoint. There's a gap there that's just a little bit too big, and it's not able to knit properly. So what can we do? So this brings me to tip number 9, and that is, in general, if you want to make sure that everything touches perfectly edge to edge, you want to overbuild those surface bodies and then trim them back. So for something like this, I can actually extend with my extend command like that, and it will repeat for the other. So you extend and then trim back. So trim surface mutual between this and that, and I can just say keep selections. I want to keep, oops, make sure we get into this box. There we go. That we can keep those two. And in this case, it also knitted it together, but in that way we were able to solve that problem by extending and then trimming back. The way I can tell that these are knit is that, well, surface bodies folder says 1, but also the edge color of a unknit surface is light blue. Whereas if you look at, well, let me see if I can get a better angle. Let me look at this one. If you look at a knit edge, it's black. It's just like a regular solid, it's black. But an unknit edge will appear as a light blue. All right, so for tip number 10, if you're trying to create a surface and you see that it's puckering or failing, you're giving that surface too much to do. Try and break up the challenge into smaller surface segments and then build it up. So an example is this. Let's say I want to close off this open hole here, and maybe I say I can do with my fill surface. So my patch boundary, I can actually right click one of these edges and say select open loop, and that'll grab all these edges. All right, so you can see that it is able to create a surface, but the surface just looks terrible. Yeah, that is so awful. I hate how that looks. And this is an example of a surface that just has too much to do. Okay, so this isn't working out for me, so let's try and split it up into more surfaces. So instead of one big filled surface, let's try a couple smaller ones. So maybe I can get a filled surface again, but instead of this whole patch, I'll instead select open tangency. And if I have fix up boundary, if you have this off, nothing will appear, but fix up boundary will have it connect the dots pretty much. And if I hit merge result, it should knit it together like that. And there we go. So for this, you know, I can foresee perhaps a four-sided patch going on along the middle. So like we can say boundary surface from here to here. And here I can either just bring some of these back, because I want to make as many four-sided patches as I can. So make that tangency to face, and this other flag tangency to face, if that's what the problem requires. So there you go, just like that. And then you have these patches here. All right, so I have this. Let's see if I can knit these together. And let me see if I can use fill surface on these last bits here. Select open loop. We have a fill surface. Merge result. And then I can just do another one on the other side. All right, so obviously I still need to set tangency and things like that, but the point is, if you have a very large patch and every tool is just kind of kicking at you, you know, just break it up into smaller bits and just work from there. All right, so for this last set, they're more minor things, but still things that can help you out. So tip number 11. Remember how I said that open edges are this light blue color? Well, you can actually change what that color is. And the benefit is that light blue tends to blend in with the background and can be difficult to see. But if I go into my options, colors, and I scroll through here, there should be edge, open edge, or something to that effect. Oh, over here. So it's called surfaces open edges. If you click on that, edit, just make it like a bright red or something like that. There you go. And we'll pretty soon see it come into play in this model, but this is actually from the old surfacing exam that I took and failed all those years ago. And you know, we'll see what happened here. So this is one that I straight up didn't answer. This is one of those things that it asked me to perform patches and then find the mass of the part. But as you can see, I just left it as a solid body because I literally could not figure out how to turn it back into a solid so I could find the mass. Because if you just have a solid body and you try to, well, there you go. Mass properties is gray because it needs a solid body specifically in order to compute them. So I just left the question blank and I failed. So what's happening here is you can see I had this surface knit. I had create solid checked on. If I hit OK, but it's still a surface. That means there's a hole somewhere. There's a hole somewhere in this surface. So here I am. I'm just spinning this thing like crazy, freaking out. It's like, where's this hole? Where is this hole? And then eventually I just moved on and I couldn't come back to it. I couldn't finish. So this last tip, get comfortable with the SolidWorks check tool. I was very close. So little did I know, next to this very sad and gray mass properties, there is this check tool. So if I open that up, make sure that open surfaces is checked on, hit check. Okay, so it detects that it's that there is an open surface. Thanks. But if you click on it, click on the results list, ooh, a bright yellow arrow appears, pointing to where the open surface is. So as you can see, this is why I couldn't close the model all those years ago. And if only I had known this, it would have made that a lot easier. I could have had the answer. This could be right for all I know, and I won't know. All right, and that's my last tip, but you know, this is called 12.5 tips. So what's a half tip for today? So my half tip is it's a little collection of neat little things that you can do with SolidWorks surfacing that is not very mainstream. They're my little personal shortcuts, if you will. So this is by no means an exhaustive list. And especially if you have some of your own that I didn't mention, throw them in the comments. You know, the more techniques there are out there, the better when someone comes across my video and then they read your comment and you help them out. So what can I do to solve this? So you can actually see it's highlighted in red. Now it's a little bit easier to see because I set the setting. But the first thing I'll tell you, so how are we going to solve this? So you might be looking at that. It's like, well, that's a one-sided patch. You can do that with a fill surface, and absolutely you could. That's all hunky-dory, but you can see it still leaves this nasty little face behind. So I'll show you something else. So the little trick is there's a secret, well, that shouldn't be a secret, command called delete holes. And for the longest time, the only way to access it was to actually select an open edge. So you click on it and then you hit the delete key on your keyboard. So delete, and then it says choose option, delete feature or delete holes. Pick delete holes. If I hit OK, it actually, you know what, let me get a section in here. All right, so looking into the center of my part, there's my hole. If I click on the open hole and hit my delete key and hit enter, it actually extends the surface around it and makes a perfect patch. It's pretty amazing. In, I believe, SolidWorks 2019, they actually added a button. They made it searchable. So if you search delete hole, there it is. It is searchable, and they actually put it in the surfacing toolbar. But if you're running 2018 and below, the only way to access it is by clicking on an open edge and hitting delete. So that's my first like super secret ninja technique. All right, my second super secret technique actually also has to do with this. So I use my delete hole command and everything is all sealed up. There are no more holes. But if you notice, I still have a surface body. If I go to evaluate, I can't get mask properties. So you might be thinking, well, just knit it and turn it into a solid. Well, here's the problem. Remember I say you need at least 2 bodies? It's not going to work. If I hit knit surface, grab that, say create solid, it says cannot knit a surface to itself. Please choose more surfaces or faces. The second super secret technique, if you find yourself in this scenario, is with the thicken command. So in a case like this, go to thicken. You can see just it looks like thicken until you pick this surface body. And if the surface body is sealed up, this checkbox will appear. And I wish they actually just leave it here the entire time. Create solid from enclosed volume. So if you have a surface that is completely sealed, but SolidWorks doesn't recognize it as a solid, it just says it's a surface, throw it to the thicken command, create solid from enclosed volume, and there's your solid body. So a third super secret technique that comes in handy with surfaces and direct editing too is what I'll show you here, is the select tangency option. So here I have this little block here, and you can see there's like this indent of like what is a control key. And let's say I just want to turn it back into a regular block. I can use my delete face command and use delete and patch if I can select all of these faces on the inside. Except that sounds like a chore because it is. So instead, I'm just going to click right click on one of the faces and just say select tangency. That selects everything instantly, and boom, it's patched. So remember, select tangency. All right, so this last super secret technique before I end this video is about filleting surfaces. So you may know that you are not permitted to fillet surfaces that are apart from each other. So I'm back to this example here, and you can see that these are separate. If I try and use a fillet command, and I try and click on the edge, it says laminar, either none of the edges can be filleted or laminar edges cannot be filleted. So what you have to do most of the time is you got to knit it first. So if you knit it and then you fillet it, and then you fillet it, you get it to work. But there's actually a way to skip one of these steps. You can actually skip the knit, and you can actually do this with face fillets. So if I go to fillet, so here's our regular fillet types. If I go to face fillet is almost magical in a way because it just creates a new surface between 2 faces, as the name implies. It doesn't care what edge it meets up at. It could not even exist. And that's what it does here. So if I pick this surface as the blue face and then this one as the pink face, you can see even though they're not knit together, SolidWorks will still create that surface and combine them together. That's cool, but it gets even more nuts. Let me get another example. All right, so here I have 2 surfaces that are intersecting. Remember, this is like the no-no of knitting surfaces. So if I try and knit these together in any capacity, it says I can't do it. And that's because it's intersecting itself. That's not allowed. But let's say that I want to create like a top of a cylinder using these 2 faces. Well, with face fillet, something pretty interesting happens. If I select this as one face and this as the other, check out what it does. It combines it together and then knits them together after it creates that surface. So when you select these 2, notice that the direction checkbox, there's some direction boxes here. So now you can play around with these to get the result that you want. So if that's a cylinder I want, there we go. Or, if I want to flip it to the other side, Just hit that. There we go. Also, I can get the outside one by flipping this box, just like that. There you go. And yeah, combinatorics, you're just going to have 4 possible permutations of this. And there you go. You can actually get them all without having to do a trim and knit step. You just go straight into fillet. And as long as you use face fillet, it will take care of it for you. Well, at any rate, I hope you found this pretty useful, pretty cool. I hope you learned something new. And of course, if you have any questions, just leave them down below. I'll do my best to answer them. And if they need a video, let's do that. Oh yeah, and be sure to follow me on Instagram and Twitter, where I'm doing #CAD model today. I post a model every single day, and I welcome questions on those as well. It's like, how did you do that? That could be a video in itself, but I need people to ask those questions. You know, I'd like to do a video on every single one, but I'm just one dude, so I depend on people asking me questions about them in order to elaborate on stuff. So follow me, Instagram and Twitter, at VirtualFlatCAD. And with that, that's all I got for you today, and you have a good one.